All right, hi everyone. Very good day to everyone here. My name is Lucas, and I'm from the tech team at BNB Chain. And the purpose of today's presentation is to dive deeper into exactly what the One BNB ecosystem has to offer. So let's begin. All right. Before we take the step forward to kind of share with you the technical deep dive, I want to do a recap on our mission, and that is actually to onboard the next billion Web3 users. And that is this mission is aligned with our vision, and that is to help developers like you build real businesses, solve real problems, and finally cross the chasm. So, what exactly is the BNB chain ecosystem? There are three main components that I want to highlight for today's presentation. First would be our BSC Smart Chain, which is our DeFi hub, our layer one. And we also offer a layer two on our OPBNB, which some of you might already have known. It is our scaling solution to help you meet your business needs with higher transaction speeds. Third, we have BNB Greenfield, which is our decentralized data storage network. It is a decentralized data storage solution, and I'll show you how all these three can come together to help you through your development. This is how a typical streamlined decentralized application stack looks like. One similarity between this and a Web 2 development stack is that you will see we also adopt the three-tiered approach in developing a web application, a decentralized application. So in Web 2, you have your presentation layer, you have your application layer, and your database layer. Similarly, with your one BNB ecosystem, you can do the same. First of all, you can develop your front end either in JavaScript, your CSS and HTML, and that is where your client will interact with. Subsequently, you're gonna have a backend or middleware that kind of communicate with your smart contracts. The business logic and the assets will be held on the smart contract itself, which can either be on BSC or OPBNB, depending on your business case. Subsequently, you can have this data communicate or stored into the Greenfield infrastructure. The Greenfield infrastructure is a decentralized database, and we are highly available through multiple storage providers. And these providers consist primarily of the primary storage providers and the secondary storage providers, which will use techniques such as shardings to ensure that you get high data availability through our infrastructure. Beyond just being a database, we also have web hosting solution where you can host your front end application directly in the Greenfield infrastructure. One very important point I want to highlight in this whole architecture diagram is that the BSC and OPBNB smart contract is enabled with cross-chain programmability with your Greenfield infrastructure. One example I want to highlight would be imagine you're running a bookstore and you have all these books held in the store in the Greenfield infrastructure. And whenever a user purchases a book, you issue an NFT token representing that book. Now that user A has read access to that book. But when that user A transfers the NFT through sale or through gifting to another user, user B, you're gonna need to have the program, the Greenfield database, to ensure that the read access is transferred to user B, and this is possible with BSC and OPBNB in our one BNB ecosystem. Moving on, there's three things I want to highlight in this presentation. First is how you can onboard users with a few of our development tools, as well as what are some existing scaling solutions. And lastly, I want to discuss how at BSC and OPBNB we increase throughput through technological advancements. First, let's talk about onboarding users. Almost in any business application, in any decentralized application, you're going to need to onboard your users to your platform. And this is where I want to share about account abstraction and EOA Pay Master. But exactly what are these? These are account abstraction basically is a protocol that allows you to achieve two things. First, it allows you to pay gas fees in different tokens. And secondly, it can help you define who's paying the gas fee. For example, if I'm creating a decentralized application and I don't want my users to be paying gas fees, I can use account abstraction solutions such as those in Biconomy. We have also account abstraction with NodeRail to allow you to define gas payments from the paymaster instead from the users. And this increases the flexibility of how you want to design your business case and your application. So as you can see, multiple solutions. We have adopted multiple solutions in terms of account abstraction, such as Biconomy, Stackup, Particle Network, Trust, Wallet, Pimlico, and TradeWeb. EOA Paymaster solution, if effectively, it will gather all Web3 users' transaction into the Paymaster, which consists of your typical RPC, proxy, your authentication, risk control, and the signing duties. Subsequently, it will pair up with, for example, transaction 2, which is paying a high gas fee to get transacted faster through the network. And finally, it will be sent to the builder to create an unsealed block together with your bundled transactions, which is transaction 1 and 2, as well as all your other common transactions, and finally to the proposer to be submit for execution. For our EOA gasless solution, our EIP 4237, we are based off EIP 4237. However, we differ in a few ways. Is that our EOA Paymaster has a lower gas fee, and we are able to integrate with a lot more wallet types and decentralized applications due to the fact that you don't need to modify your smart contracts, too much of a smart contract, in order to work with our Paymaster. We've left a link at the bottom, which is the documentation to Node Rails link on how you can use the BSC bundle service API. All right, now moving on to scaling solution. And my apologies. And this is very important for decentralized applications that requires fast transaction speeds. And this is where we want to actually introduce to you this tool, which is known as a rollup as a service, which can be a gaming layer 2 on BSC. First, let's talk about blobs. Blobs are data that is available on your that is used to segregate payload data with your transaction data, such that we make the entire chain run more efficiently. And we achieve this by ensuring that all these data are segregated, and you'll be able to actually send it through the transaction to the execution layer, and after a certain number of days, similar to the EIP version of this, it will actually take that blob away and allow you to reduce blockchain bloat, yeah, in a sense. And there's a link over there, which is our BEP 236 proposal on how we evolve the BNB smart chain with blob transactions. What happens after this blob data, after we've detached it from the chain, is that you can either let it detach and be gone, or more often you will want to archive them for future references. And we do offer this our blob archive service built on the Greenfield infrastructure. And this is also available through reference on our GitHub, BNB Chain, where we call it Blob Hub. The Greenfield Blob Archive service supports both the Ethereum mainnet as well as our BSC mainnet. BSC Layer 2, our Layer 2 scaling solution, also offers fast finality. And what do we mean by that? Typically on a Layer 2 solution, all the transactions will be bundled together, sent to Layer 1, and it will only be finalized on Layer 1 before it can be finalized on Layer 2. And our partners have come up with this new Mac AVS kind of concept to allow you to achieve faster finality on Layer 2 itself. And what typically happens is that the Mark AVS operators, operator 1, 2, 3, they will replay all of these transactions and have the ETH Eigenlayer Manager kind of manage and oversee all of this finalities, these replays, and finally achieve consensus on the Layer 2 itself without the need to be sent to Layer 1 for finality. Ultimately, this transaction will still be sent to Layer 1 for finality, but it can achieve consensus on Layer 2. Now, this is the BSC and OP-BNB parallel EVM, which I will be covering later on how we also use parallel EVMs to increase performance on our chain. With the Mark AVS, we have also enabled fast interoperability. Assuming you have two chains, which is rollup A and rollup B, you want to cross data between these two rollups. In order to do so, you're gonna need finality on layer 1. But with our mark system, you will be able to achieve finality on the consensus itself, allowing data exchange between the two rollups seamlessly. Now, throughput matters, and this is where I want to share more about our parallel EVM that has been implemented on our BSC and OP-BNB chains. What exactly is parallel EVM? Assuming you have a few transactions 1, 2, 3, and 4. You pass it through the execution instance, and what typically happens is this. Let's say transaction 2 dependent on transaction 1. We'll run transaction 1 and 2 in parallel, and the conflict detection system will notice that transaction 2 cannot be executed first. So it will take transaction 2 and rerun it from the start. And this is how a typical parallel EVM would work. However, it causes a lot of plenty of conflict detection, and it is inefficient. There are 4 ways where we can solve this problem. First was the method that I've mentioned, and that is known as static dispatch. Or we can use transaction-directed acyclic graphs. And later I'll share more about that. Subsequently, there are other solutions like static analysis or a hybrid approach of static analysis with transaction-directed acyclic graphs. So how does BSC and OP-BNB utilize the transaction-directed acyclic graph to implement our parallel EVM? So imagine this. We have transaction 1 to 9. And on the left, we map the kind of relationship to it. So transaction 1 depends on 0. Transaction 2 depends on 1. And transaction 4 also depends on 0. As well as transaction 3. And transaction 5 depends on transaction 4. So there are multiple dependencies. With a parallel EVM that doesn't use our transaction DAG, how it will look like is as such. On the top right table, you will see that there's transaction 0, 1, 2, 3 sent for execution in parallel. The validation will show that transaction 0 passed. However, transaction 1 and 2 would fail because they depend on transaction 0 and 1 respectively. And then what will happen is transaction 1 and 2 will be replayed together with transaction 4 and 5, and you'll see that transaction 1 passes and all other transactions fail. So this leads to multiple failure and conflict detection, and we will show you how transaction DAG can solve this problem. On the table on the left, you will see from those relationships, we map out this directed acyclic graph. It is a list that represents the dependencies for each transaction. For transaction 0, transaction 3, transaction 7, and 9, you'll see they have no dependencies at all. So we'll pass this for transaction into execution. And that's how, as you can see in validation, the transactions pass. We'll continue passing on to the next, passing on the next transaction in, which is transaction 1, which can be executed because transaction 0 has passed. And upon validation, transaction 1 has passed, and then we'll pass on transaction 2 and 5. Subsequently, all of them will be successfully executed with minimal conflict detection. And this allows us to run the EVM in a more effective and efficient manner. We have also proposed this hint-based approach, and the hash of this transaction-directed acyclic graph will be a fixed 32 bytes added into the block body. This also assists with the prefetcher system. And what the prefetcher system does, in a sense, is that before having the transactions executed by the processor, it will fetch the necessary data from the chain, such as your wallet balances, and things like that, before even before it gets processed. So the data is readily available. So with the transaction-directed acyclic graph, we'll be able to fetch according to the execution order on what can be executed first. And the prefetcher will fetch, for example, transaction 0, 1, 2, and 8, and have them ready for the processor to use, increasing the cache hit. There's a link at the bottom, which is the forum URL regarding our BEP 396 on how we can accelerate block execution through transaction-directed acyclic graphs. So moving on, that covers the 3 tools that I would like to highlight for this presentation. I want to highlight, dive deeper and kind of share with you more about the other developer tools available on the One BNB ecosystem on BNB Chain. So this is the link to our website where we have, a whole bunch of developer developer tools that can help you in all different aspects depending on your use cases. So feel free to scan this QR code, visit the link, and yeah, use them. I'll leave this here for a few moments. Okay. Now, if you face any technical difficulties when you are trying to interact with either BSC, OPBNB, Greenfield, or you have some technical issues that you want to ask, feel free to check out our Discord channel. Discord channel is where you can raise a ticket. You can simply do the slash ticket and on the Discord channel, and we'll raise a private channel. And this private channel is where the global team at BNB Chain will assist with all your inquiries and try to help you solve any issues you have integrating with BNB Chain. There's supposed to be a video here, but okay, that's okay. So scan this QR code to join our Discord channel, and you will be able to access our real-time support, which where we promise to help you through all your development issues. All right, now moving on to the scoring process of this hackathon. So this hackathon, first of all, we'll do an initial screening during the submission, and we'll select top 10 teams to enter into demo stages. And the second part, we'll have an online public demo and scoring. And lastly, we'll announce the winner. So a few things that I want to highlight. So the basics pillars that we'll look at in the scoring criteria is that the design and usability has to be good. At the end of the day, in order to onboard the next billion Web3 users, we have to be user experience first to ensure that there's minimal friction for users to be onboarded into your solution. It has to be scalable. We have to be able to serve millions of people. As much as possible, if you're an open source project, that would have bonus points. It has to be an innovative idea that hopefully it doesn't exist or is a variant of existing solutions, but ultimately it has to solve the problem in a more effective, efficient way. If your problem statement is part of this Q4 hackathon suggested topic or within our community wish list, you will also be given additional scoring. And lastly, it has to be feasible and eligible for incubation. It has to have business value where it serves the business model has to be prudent and be able to sustain the entire project. A few tips for you: you can take a photo. These are available in some of the documentations. And first of all is to verify your contracts on Explorer. Make sure that full open source codes, your reasonable commit history, and make sure that your commit history do not start before the hackathon, because past projects are disqualified and not allowed in this hackathon. Demonstrate your roadmap, to give us clarity on exactly what are the future developments. This hackathon, you might not be able to build the full picture, the full solution. So you can include in your roadmap exactly how the final product will look like and what are the different phases of development. Provide clear documentation, tutorials, as well as videos to help us understand your idea better, understand your codes as well. And if possible, engage with communities or users to gain feedbacks on how you can improve your products. Clear business model, as mentioned before, and sustainable revenue generation, so that this can be a sustainable solution that will serve the community. And as mentioned before, it has to be innovative, and we suggest that if you choose wishlist challenge, please read the requirements in detail, which is published into our GitHub. So a few things you must take note for the submission itself. Please share all your artifacts, which includes your GitHub link. Make sure it's public, your pitch deck, as well as the demo video. Ensure that your smart contract addresses has at least 2 successful transactions within the hackathon time frame, and they have to be related to your project, not just 2 random successful transactions. And lastly, tweet a description describing your project and tag BNB Hack and BNB Chain. A few last tips that I want to mention as through a few observations from past hackathons is that, yes, this is a common question. You can build ideas out of the hackathon, suggested topics, or BNB Chain wishlist. You're free to build anything, and if we do see value in it, you will be eligible to win as well. Your projects must not have been participated in other hackathons or previously funded and it must be a new development. So we do check your GitHub repositories, your idea, and we try our best to do due diligence to check whether it has been a previous project. So try not to, because we have disqualified teams before because they are using past projects for our hackathon. Utilize at least one of BNB ecosystem technologies. You don't have to use all three, but use at least one of them. It can be BSC, OPBNB, or Greenfield. More importantly, I want to emphasize is that use these technologies wisely based on use case basis. You don't have to use them just because you just want to use all three. Make sure that all of them serve a good purpose on how you can deliver a solution to a problem. Well, and that's about it for my presentation. I hope I don't take too much of your time. Thank you and happy hacking.